All right. We are starting part 2 of going over the chapter 6 review. So here we have some trapezoid problems. This one is actually an isosceles trapezoid. So because of these markings here, saying these legs are congruent, remember these are the legs. And these would be the bases, base, base. And base angles are congruent in an isosceles trapezoid, so both of these would be the same. They would be y, and these would also be considered base angles. So base angles. So these would also be congruent. And all that stuff is actually just marked on there. Just kind of reviewing some of the stuff about isosceles trapezoids. So we're supposed to solve for x and y. So x is pretty easy. These legs are equal. Okay, I'm going to go ahead and subtract x on both sides. I get 1 equals 2x minus 4. I'll add 4 and get 5 equals 2x divided by 2. And that's going to give me 2.5. All right, so x is pretty easy. Second part here is to solve for y. In a trapezoid, any trapezoid really, these angles here that share a leg are going to be supplementary to each other because they are same side interior angles. If you stretch out the parallel sides here, and then you think of our leg as a transversal, they are on the same side in between two parallel lines. So again, that makes them same side interior angles. So they're going to be supplementary. So in this case, we know, again, those angles are supplementary, so we have 4y minus 20 plus y equals 180. Simplifying that, 5y minus 20 equals 180. Go ahead and add 20 to both sides, so that's 5y equals 200, and then divide by 5, you get 40. So there we go, 40. And we could take that and figure out some angles, like this one would be 40 degrees, and this one would be 140, since it's supplementary to that. Same over here, 40 and 140. All right, and again, we could have also used the value of x to figure out that these were 3.5 each. All right, moving on to the next problem. Again, we have another trapezoid. This is another isosceles trapezoid. Remember, we know that means that the base angles here are congruent. If they share a base, they're congruent because this is isosceles. That means if this is 135, so is angle 3. And then 1 and 135 are both supplementary to each other. So 180 minus 135, that's going to be 45. So this is a 45-degree angle, 45. My toolbar's in the way. There we go. This is a 45-degree angle, and again, same over here. Once you know one angle in an isosceles trapezoid, you will be able to find all the rest. Moving forward, here we have some problems involving no picture, and in order to solve them, we're going to need to draw a picture ourselves. So we have a rhombus. I'm going to go ahead and draw a rhombus. Doesn't really matter what it really looks like. I'm just going to sketch out any old rhombus. Remember, all the sides are equal when we make a rhombus, so trying my best to make that the case. So there we go. Here's a rhombus. I'm supposed to name it P, Q, R, S. Notice how I just kind of went around the shape with the name. That's what you want to do. You don't want to like bounce around. You got to go around the outside consecutive vertices. And we have some diagonals, PR and QS. So PR is a diagonal. That looks fine. And QS is another diagonal. Okay. Let's take the rest of this information here and kind of mark it up. So measure of angle PRS is 51. So PRS, so that's this angle right here. And this is 51 degrees. So there are a few properties of rhombuses that we need to keep in mind as we're working on this particular problem and probably a couple others. So let's go ahead and enumerate those right here. So first one is that the diagonals are perpendicular. So that means that the diagonals intersect at right angles. And then the second one that's going to be useful here is that the diagonals are bisect. Sorry, bisect the angles. Third one that's also going to be useful here is that the opposite angles are congruent. Okay, going to kind of use a mixture of these. There are other properties that rhombuses have, but this is what I'm going to use here. So first one is really great. It means that all of these angles here in the middle are 90 degrees. That is useful. Also means that this angle here, oops, is going to be the same as the 51-degree angle. Those are equal. Same over here. These two angles are going to be equal. And then over here means that these angles are also going to be equal. Trying to label them all clearly. So angle Q, the biggest angle here is bisected. This angle down here is also bisected, bisected, bisected. And since the opposite ones are equal, the halves are going to be equal as well. The halves are going to be equal as well. All right, so let's go ahead and actually try to answer this question. So it says to find the measure of PQR. So PQR, I went ahead and highlighted that angle. So we're looking for this entire angle right here, PQR. So we need to kind of do this in pieces and find both of these or one of them and kind of double it to find the whole thing. Easy enough. If I just focus on the triangle down here, there are a few ways to go over this. This is the way I'm going to do it. I'm going to focus on this triangle down here. I've got a 51-degree angle, a 90-degree angle, and an unknown. And that's the same as these. So let's go ahead and do it that way. So that means 90 plus 51 plus, we'll call it x, plus x equals 180. These add together to be 141. And subtract 141, we get 39 degrees, right? I think 39 degrees, yeah. So that angle here is 39. That means each of these here are also 39. And overall, this angle, the measure of angle PQR, is 39 plus 39, or 78 degrees. Again, I could have went ahead and found like all the angles here, but I just wanted to focus on the one that we were actually looking for. Let's move forward. Next one, square, LMAO. So let's sketch a square. Square, remember, right angles and all sides the same, so just do your best to make that happen. And we also have some diagonals for a square, so go ahead and do that too. Okay. So it doesn't matter where we start, we'll just do it here. It has diagonals LA, so that's this whole diagonal. Okay, so this whole diagonal here is 4x plus 7. And the other whole diagonal, MO, is 10x minus 41. Okay, so the thing to keep in mind with squares, because we do have a square here, they have all of the properties of all the special parallelograms. So all the properties of parallelograms, all the properties of rectangles, all the properties of rhombuses. We're going to make use of two important properties. Well, actually, that's not even true. We're going to make use of one property of rectangles. It is true for all rectangles that the diagonals are congruent. So these two things are simply equal to each other. Easy enough. 10x minus 41 equals 4x plus 7. I was going to say I thought maybe we were talking about half these diagonals, but if we were, all of these halves are equal as well in square. But in that case, that doesn't matter for this problem. So anyway, let's subtract 4x. 6x minus 41 equals 7. We'll add 41. 6x equals 48, and that gives me x equals 8. We are supposed to find the length of LM, so that's this side right here, LM. In this case, it's a little bit tricky, but if we think about it like this, where we're only, I should have used the line tool. Let's undo that. Let's just use the line tool. So this is the top LM. This is the side down here. This is AM, and this is one of our diagonals. What you'll notice here is we created a right triangle. We know these are equal to each other. So we've actually created a 45, 45, 90 triangle. And we're going to know the hypotenuse because we can just use this value to figure it out, right? It's 4 times 8 plus 7, which is 32 plus 7. This is actually 39. So we can figure out for us, which is going to be LM. This is kind of a annoying little problem, but it's not too bad. We could use the Pythagorean theorem. We could use 45, 45, 90 relationships. Doesn't really matter. I'm not going to quite ask you one this difficult on the test. So I'm going to stop here and just say, pretend we were asked to solve for that. Now, if you want to know the answer, right, we could set up a Pythagorean theorem. It would be x squared plus x squared equals 39 squared. 2x squared equals 39 squared. Divide by 2. We get x squared equals 39 squared over 2. And when we take the square root, we get 39 over the square root of 2, which needs to be rationalized, which is 39 root 2 over 2. I could get a decimal for this. That might even be more appropriate, but I'm just going to leave it like that. You can do the decimal calculation if you want to check your work on it. All right, here we go. Kites. So in these next set of problems, we're going to examine kind of a bunch of different angle relationships inside of special parallelograms. So here is a kite. A couple things with kites. There are 4 right triangles here because, again, like rhombuses, these diagonals are all perpendicular to each other. So all these angles in here are 90-degree angles. We have actually 4 right triangles. And actually, we have some matching pairs, like this triangle up here, this one, this triangle, and this triangle are congruent to one another. So you can use sort of CP-CTC to help you out in matching those up. And these 2 triangles here are also going to be congruent to each other. I'm going to go ahead and erase some of that stuff. The other thing that we know with kites is we do have some congruent angles. So this whole angle here and this whole angle here are congruent. And then these angles are cut in half. 1, 2, 3, 1, 2, 3. So a lot going on with kites in terms of the angles that you need to keep in mind. Again, I'm going to erase all this stuff and try to work this problem out a little bit. All right, so the 51-degree angle is right here. We are looking for angle 3, so that's pretty easy. We just can look at this triangle, this right triangle right here. We know 2 out of the 3 angles. We have a 51, a 90, and angle 3, so you can find that out pretty basic. These actually need to add up to 90 together. So 90 minus 51 is 39. So angle 3 is 39 degrees. Not a great color, but that's okay. Angle 2 is actually going to match 51 degrees there, so it's also 51 degrees. A couple ways we can go about this, but 60 degrees and this one are the same. They're in the same position in those triangles. So we have 90, 60, 30. That would add up to 180. So angle 4 is 30 degrees. And obviously angle 1 is here. It's a 90-degree angle because of the perpendicular diagonals. A lot going on with the angles in a kite, but with a kite, what I would say is if it looks the same, it probably is the same. Okay. Moving forward with rhombuses. So again, rhombuses have a lot of angles that are going on. First of all of our angles in the middle here are 90-degree angles because the diagonals are perpendicular. And then the opposite angles are congruent. So this whole angle here, I guess MJK or J, this whole thing and L are the same. And the diagonals bisect, so these halves are all equal. So all 4 of those angles are actually the same. And then it's also true with 3, 4, and these here. So we have a ton of congruent angles in our rhombus, especially when the diagonals are all drawn in. And actually, essentially, all 4 of these triangles that get created are actually all congruent to each other. Pretty easy to see that all the angles are the same. And remember, this is a rhombus, so since that's true, all these sides would also be congruent, so we could pick any sort of triangle congruent shortcut we wanted to show this, angle, side angle, or something like that. I'm going to erase some of this here. Anyway, our point is, let's find some angles, so let's do it. So this one's 37. So we have a right triangle here. I can kind of outline it for you. Um, 37 and 3, these have to add up to 90 together because we have a 90-degree angle in there. So if we do 90 minus 37, 90 minus 37, we get 53 degrees. So this is a 53-degree angle, and 4 would be the same. And obviously 2 is here in the middle. This is a 90. So hopefully we can see all the angles that we have here, and we could basically fill out all of the rest of it just with kind of those 2 numbers. Anyway, next problem, parallelogram. A couple things with parallelograms. Quickly, opposite angles are congruent, so this is 83 also. The other thing to keep in mind is parallel sides can create some alternate interior angles. So if I draw this sort of Z shape for you, I think you can see the alternate interior angles that are getting created. This, what is that, a 56-degree angle, and this angle 3 are the same. So 3 is 56 degrees. The same thing is actually true kind of the other way. So if I draw those as well. So angle 2 and angle 1 are actually the same. So whatever we get for one of those, the other one will just be the same because they're alternate interior angles. They're between these parallel lines, different sides of our diagonal, which is servicing as our transversal. Anyway, our shape is split into 2 triangles. So 83 plus 56 is 139. So 180 minus 139 is 41. So this is a 41-degree angle, and 2 would be the same. Or 1 and 2 would be the same. A couple of these measurements seem a bit off, but you know, we can't always trust the scaling of the drawing to match. We got them based on the numbers, so, and the properties, so we know those are right. Okay, let's go to move forward, looking at a rectangle. So a lot going on with a rectangle. Obviously, rectangle, we know that means that these are all right angles here. So right angles. So 6 and 8 are complementary, 5 and 2 are complementary, 65 and this angle over here are complementary, and these are complementary because those are all right angles. It's a rectangle. The other thing to keep in mind is since the diagonals actually bisect each other, we actually just create 4 isosceles triangles where the top and the bottom actually match each other, and the left side and the right side match each other. That's a little more advanced. Let's kind of examine what that means for the angles. What that really means here is 65 and 65. So these 2 angles are the same, and they actually match 6 and 5. So these are both 65-degree angles. And then we could use our complementary relationship over here to figure out that this is 25. And this is 25 because, again, we have our isosceles triangle right here. So those base angles would have to be equal. Anyway, and then from there, this triangle matches that. So this one's going to be 25 also, or complementary relationship, 25 also, or complementary relationship, whatever you want to see. And then we can kind of start figuring out these middle ones. Well, 25 plus 25 is 50. That leaves 130 for angle 1. 130 plus 50 is 180. 7 would be the same. Vertical angles, linear pair here. That means angle 4 is a 50-degree angle. Could use triangle sum all over the place as well. Doesn't really matter. There's lots of different ways to go about solving this one. All right, 2 more main problems to look at. So in this problem, we're going to try to decide whether these statements are always true, sometimes true, or never true. So we want to break this down. Always true means there's no way to have, so for example, let's look at A, no way to have a rhombus that's not a square. It will always be true. If it's sometimes true, it'll be like, well, sometimes a rhombus would be a square. I could draw an example where it is, and I could draw an example where it isn't. That's sometimes. Never means there's no way I can make a rhombus that is a square. So we have to keep in mind what all of our defining characteristics are as we're doing this. So what makes something a rhombus? It just means that we have congruent sides. That's it. That's all we really need to know for congruent sides. Square has that same property, for congruent sides, but it also means 90-degree angles. So is this sometimes true, always true, sometimes true, never true? This one is a sometimes, because we could draw a rhombus as a square, but we could also draw a rhombus that's not a square. So this one's going to be a sometimes true. I'm just going to write an S for it, sometimes true. All right, let's look at the next one, rectangle. Rectangle is a trapezoid. Okay, a rectangle means we have 4 90-degree angles, so 90-degree angles. It also is a parallelogram, right? Parallelogram, because both sets of sides are actually parallel to each other. When we have these 90-degree angles, we do actually create parallel sides here and parallel sides here. So that's about a rectangle. A trapezoid has a very specific definition, at least as far as our textbook is concerned. A trapezoid has exactly one set of parallel sides. So only one set. So since a rectangle has two sets of parallel sides, it cannot be a trapezoid, because a trapezoid says it has exactly one pair. And this word exactly kind of weeds it out. So this one is a never. All right, next one, C. A parallelogram is a rhombus. Okay, this is one of those situations where we could draw both. We could draw a parallelogram that is not a rhombus, kind of have longer sides and shorter sides, and we could draw a parallelogram that was a rhombus, where they're all the same. So this one is sometimes. Remember, the only thing we need to know for something to be a parallelogram is that these opposite sides are parallel to each other. Doesn't mean that they're all actually congruent to each other, but they could be. So this is sometimes true. Next one, a square is a rectangle. So square means we have 4 right angles and 4 congruent sides. Well, a square is always a rectangle because it always has the defining characteristic of rectangles, 4 90-degree angles, 4 congruent angles. So this one is an always. And then the last one, a rhombus is a kite. All right, so while a rhombus means that we have all 4 sides that are congruent, and a kite means that we have consecutive sides that are congruent. Now, there's some leeway here. There is kind of some wording in our definition of a kite that does mean that they can't all be the same. That's not always the case. So this one's kind of, it could be like this one, where there's something about the definition that doesn't allow it to work. Or it could be that it is sometimes true or always true. I'm kind of flexible either way as long as a good explanation was given here. I'm gonna go with never because I think our textbook has a pretty restrictive definition for kites. It says two different sets of consecutive congruent sides. Consecutive congruent sides. And this word different kind of rules this out. So I'm going to write never for this one, but if you argued differently, I wouldn't necessarily disagree with you as long as your explanation was good. All right, the last one, let's determine the best name, the most descriptive name based on these markings. So this first one here, we have 4 congruent 90-degree angles. That's a rectangle. And opposite sides are the same, but they're not all the same. So yeah, I think this is a rectangle. Here we have 4 90-degree angles and 4 congruent sides. That is the defining characteristics of a square. Here we have congruent side, congruent side, congruent side, congruent side. Consecutive congruent sides, that makes this a kite. Here we have a trapezoid, but actually an isosceles trapezoid. Trapezoid. And then here we have 4 congruent sides. That is our defining characteristic of a rhombus. All right, that's part 2, guys. Good luck on your test, and see you in class.